Okay, today we're going to do a low-cost aluminum baluster cable railing system that goes across the mezzanine on the garage, down the stairs. We're going to focus on low cost but with a nice finished look. We're going to use base materials versus buying a finished kit. And the system in the end will cost about $22 per linear foot of materials. And at the end of this video, I'll show you the cost of each item and where it was purchased. You can certainly fast forward if you want to see that earlier. This is a picture of the garage, mezzanine, and stairs prior to putting in the cable railing. We're going to install 18 aluminum balusters and run 12 strings of cable railing. This is a picture of the finished product with the cable railing running across the mezzanine down the stairs. In this video we will step through the treatment for each baluster as well as the hand railing and the attachment and so forth. This is my garage. The upper floor is the mezzanine, which will be an office. I'm going to put the cable railing along the edge of the mezzanine and then down around the staircase. And I'm going to use these aluminum angle iron as the balusters. These are an 8-inch thick, 1.5 inch wide on each side, and 4 feet long. I plan to drill into these balusters 2 holes to mount them. And you can see the line on here is about 8 inches off the bottom, which will be how deep it will go as it mounts to the mezzanine or the staircase, so 8 inches down. And since they're 4 feet long, it'll leave 40 inches up to the top. I'll put a handrail across the top, and I'll drill about 3 1/8 inch distance between every hole to mount the cable railing. In this slide we show some of the calculations for how many balusters to put up and what are the distances between the cable railings. In this case I wanted the balusters about 3 feet apart, and we had 26 feet 4 inches, so it comes in just under 36 inches apart each. And the cable railing holes will be 3 1/8 inch apart. You can also see the calculation for how many feet of cable is needed total. This slide shows the measurement for the upper staircase, which is 11 feet 6 inches. We'll have 5 balusters. However, the top baluster will be shared with the rightmost baluster of the mezzanine. In the end, these balusters won't be equidistant apart because they have to be connected to the end of a stair, which are, the treads of the stairs are about 8 inches wide, so they won't quite be equidistant apart. In this slide we showed the lower staircase measurements. There's the stairs itself, which is 6 feet 6 inches, and then there's a landing of 3 feet 11 inches. There's 5 balusters total, the landing being flat, and then it takes about a 37-degree turn down for the stairs. So it will be a little bit of a challenge to keep the cable railing from looking bent. These are 1.5 inch angles, 1/8 inch thick aluminum. And what we've done here is drilled holes, you can see, every 3 1/8 inch. We're going to use 1/8 inch cable, so the hole size needs to be slightly larger than that. And I would suggest not getting a drill bit that's so tight that you have to thread the needle every time. Get something that has some space to it. So the way these are going to mount, you can see 2 large holes here, and what's going to happen is we're going to put in some 3-inch lag bolts, and that's going to hold this baluster up against the mezzanine. So the lag bolts will go directly into the mezzanine, and we'll leave about 8 inches of the aluminum below the mezzanine floor height. And since this is 4 feet, it'll leave 40 inches
up for the cable railing. And the reason we chose 3 1/8 inch hole spacing is basically some of the city ordinances require that you cannot spread the cable railing more than 4 inches apart. So if you start with 3 1/8 and you keep your balusters relatively close together, something in 3+ feet apart, you should not be able to spread it more than 4 inches apart. And the intention is so that a child's head does not go through the cable railing. So I'll show you the lag bolts in a second, just so you get a better idea. But my good friend Wayne spent yesterday drilling almost 300 holes, because we will likely run 12 cable rails per baluster, and there's 20 balusters plus the 2 lag bolt holes in each one. It's a lot of drilling, but luckily it's aluminum. So next we're going to sand these, then we're going to use etching, self-etching primer, and then we're going to paint them a flat black color. This is a Muzata, M-U-Z-A-T-A cable, stainless steel 1-inch cable, 600 feet long, and the cutters, as well as the crimper. This is a hydraulic crimper, hand pumped. I got the 1/8 inch, so it comes with these bits that will crimp, and I'll show you that in a minute. The cable, it's a stainless steel, they call it rope, and 600 feet's just about what I need for this job. Cutters for the cable, and then Muzata, the specialty items that they sell. The first piece, we'll just talk about how this is installed. This is a very simple piece of steel where you slide a cable end into it. You take the crimpers, you crimp this so the cable stays there. It goes into one of your balusters on the end. This is basically an end cap. Then on the opposite end, you run the cable until it gets to about this deep in this end of it. This is the far opposite end baluster. And then you crimp this, and then this threads into this end cap. So this will thread inside. And then this has a Allen wrench opening, and you twist this. It goes into the far, say, left side baluster. And as you twist it, obviously it gets tighter, 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 and this is what tensions your cable railing. So I got a pack here of total of 20, 20, 40, and same here, 40. And then this is a 30-degree angle that I will put at the bottom and potentially at the top of the balusters that are on my stairways. So when this piece and the other end go through the baluster, they're pointed at an angle, 30-degree angle, instead of coming through flat and then sort of crimping up. And the drill bits, this one was suggested as a 9/64 to drill for the 1/8 inch cable railing. However, we found that to be a little bit small. We went a little bit bigger with the hole. And then this one is a 7/16 to drill the hole for this one. Okay, more in a little bit. So today we sanded the balusters, 120 grit sandpaper, and mainly it's to create a roughness on the aluminum so that the primer will stick. And we also finished drilling out the holes to the proper sizes. We used Rust-Oleum self-etching primer, and I'll show you a picture of that in a moment. The self-etching essentially sticks to the metal much better than a typical primer. Also with the sanding, it helps the adhesion as well. We put on 3 light coats, and that's this sort of gray color you see now. And in between each coat we wait 5 minutes. And then we wait at least 1 hour to put on the final coat of paint, which will be Rust-Oleum, probably a flat black, and when the black paint goes on, it'll go on a very similar way. 3 coats, 5 minutes waiting between coats. And regarding the holes that we drilled today, so this is a corner baluster. We decided to use it. It'll be basically up in the corner of the mezzanine there above the closet door, and it will service not only the top of the mezzanine running right to left, it'll be the far right post, it'll be the very top post of the long staircase. And so this post is unique. We've drilled both sides of it, and what'll happen is we will bolt it to the mezzanine here with 2.5-inch lag bolts. Then the end piece for the down staircase will go through here. So we'll put the cable in and crimp it. And then we offset the hole by 1/2 inch, and you notice it's much bigger for the tensioner. So the mezzanine tensioner will go through here and the down staircase here. So the cables will come together. And same way with all 12 cables. And then in other locations, like the far left of the mezzanine, we have a post that's merely drilled for, the end cap terminator for the cable. And many of the other ones are merely drilled for the cable hole. So the cable will run through with no terminator and no tensioner. This is the self-etching primer by Rust-Oleum, and this is what we use to prime these balusters. We've decided to use flat black Rust-Oleum paint, this ultra cover, which claims to have primer also, but I think you're better off using the self-etching primer first on the aluminum. So flat black it is. Today we're putting on the flat black paint coat. We have 2 coats on so far. We'll do a 3rd coat. We'll let 5 minutes go by between each. Typically actually about 10 minutes between each. And we've already done the back side with 3 coats. This is the front side. After this we will be done with the painting. Okay, so we have installed the balusters, and these are all bolted in place, leveled, and the cable railing has not been run. I did run a simple 2x4 down the stairs just to make sure we aligned the balusters correctly. The baluster is bolted in with a 5/16 lag bolt, and we used about 3 inches depth. Next, we'll start running some of the cable railing, but what I'm waiting for is the upper banister, because without the banister you cannot tighten the cable railing. The banister is what really keeps each baluster apart. Okay, one of the other things I wanted to show was just the cutting of the cable. I have the Musata cable cutters, which work quite well. They stayed sharp during all of my cuts. And I see online that some people think that these go dull and so forth. I didn't have that trouble. They worked fine for me. I would say whatever cutters you use, make sure they're sharp, they cut through quickly, and they do a clean cut. If you get a messy cut, you're going to spend all your time trying to thread the needle with a fuzzy end of a cable. So just squeeze it, and then just a push with a hand, it's not much. And the cut's done, the cut's quite clean. So, yep, I didn't have any trouble with these at all. Okay, I want to talk about the crimping of a cable. We have one of the cable ends here, and the terminators. We'll slide the cable in, and it goes in about maybe 1.5 inches or so. The crimpers are pretty straightforward. These are the ones from Musata. 1/8" die inside, which come with them. And we have what they call on and off, but basically it's release and hold of the crimper. And so as you pump it on, it crimps, and you put the cable and the tensioner in, just slide it into the slot. On these end ones, I do 2 crimps, one near the cable end, so just pump, pump, pump until it gets tight and squeezes and performs the crimp. And then I move it down and do it again. And I'm not doing this one, I don't need to, I already have one done. And what you end up with is a cable end where there are 2 crimps, one crimp here and one crimp here. So it's quite tight, it's in good condition. And then this just slides into the balusters. And once you slide it into the balusters, get it to the tensioner end, make the measurement and do the cut. At the other end, after you've done the cut's typically done by putting the tensioner end in about that far, 5/8 of an inch or so, and measure it to the tensioner, roughly to here, and then make the cut. So in this case, we would cut it here. Then we do exactly the same thing, except this only gets 1 compression from the crimper. So just in, pump, pump, pump until it's crimped, and you're done. Today I finished all of the cable railing, put in the ends, the wires, the tensioners. I'll show you some of the pieces. Keep in mind these are not tensioned yet, they're just close. So here's the tensioner end. Note that I make the curve down the stairs and to the terminal ends. And frankly, if I had to do this over, I would have made the holes bigger where the cable passes through. You can see a slight inflection as it passes through the hole. If the hole was bigger, it wouldn't have that. Very similar to the tensioner holes. The flat ones are fine, you can drill them straight. But the ones that go up at an angle, you really need to drill the holes at an angle that allows them to move more freely. And similarly with the terminals at the end, these holes were drilled bigger, so I didn't need to drill them at an angle. Once I get the banister, and what you see there is just a test 2x4 for a banister. Once I get the top banister on and get the tops of these balusters bolted to the banister, then I can fully tension, because the banister keeps each of the balusters apart and keeps them from being pulled together by the tension. One small bit of uniqueness that I want to show you is this terminal post at the top of the stairs. In most applications, they show using 2 posts, one for the stairs going down and one for the railing going across the mezzanine, but I decided to combine it into a single post, and it's worked out quite well. You can see the terminals for the cable railing going down the stairs, and then the tensioners for the cable railing going across the mezzanine, and it's in a single post. I basically offset these by a 1/2 inch so they could pass each other. My good friend Wayne spent the time to drill all of that. This is nearly 600 feet of cable railing. Across the top here, 12 rows of cable railing, and then of course down the stairs and the second set of stairs. I put these posts just about 3 feet apart. I live in Dallas, Texas, and they have an ordinance about how far apart these, well, any any railing can be. And basically you want to keep it within 4 inches. They're trying to keep a child's head from going through it. And so we have drilled these at 3 1/8 inches, but once they're tensioned, they will not be able to spread very far apart. And then at the floor level, you can see it's even less than in between than the 3 1/8 inch. This worked out rather well. On the stairs, I put a skirt board at the bottom, and the skirt board also helps fill in some of the space, so I didn't need as many rows. I went originally had planned on 13 cables and went to 12 in the end. I wanted to show you the hand railing that I've chosen. This is a red oak handrail. They call it a side handrail, I think, that Home Depot sells. It's about $4.50 a linear foot, and I am going to mount it and of course cut it for the top railing, and then I'm going to put on angle brackets to attach it to these aluminum angle balusters. And if it's not clear, I'll show you in a few minutes what those angle brackets look like. Basically drill into the wood, drill into the baluster, and attach each one. Today we're preparing the handrails for getting it stained, and then going to let it dry 24 hours, and then we'll start installing them. These handrails are just basically an oval of red oak, and they were about $4.50 something a square foot at Home Depot. Got different sizes. The longest size possible is 16 feet. I could not even find that. 15 was the longest. So on the mezzanine, we're going to do a 15-foot and about a 12 plus, and combine those together. And then about 11.5 feet down the first set of stairs, and a 4 feet and a 6.5 foot piece for the rest. Preparation for this is pretty simple. I mean, you can get pretty ornate if you want to, but basically some light sanding to get any of the burrs off. I took denatured alcohol, which is also isopropyl alcohol, which is also wood grain alcohol, and wiped them down. Got all the stickers, price stickers and so forth, the glue off. And then I'm going to use this Olympic Elite, and it's exactly what was used. It's a semi-transparent, exactly what was used on the glue lamb board of the mezzanine. So essentially this color. And this is usually used for outside deck stain, but I think it'll be okay internal. As I said, you can get more fancy and finish this like fine furniture if you want to, but I believe this will do the job. Here is a small sample of the color on the red oak, so it looks okay. And it's just a wipe down with this or brush it on. Wait 24 hours and you're ready to go. More later. Here's a picture of the red oak after the staining. As you can see, it accepts the stain quite well, and yeah, it looks very reasonable. Very simple wood finishing. I made all the initial cuts on the hand railing. The stairs are at about 35, 37 degrees down. So the hand railing cuts shared that number. This one was cut to a total of about 37 degrees. So 18.5 on each of the handrails. Then I bought some black pieces of angle to connect the hand railing to the aluminum balusters. And you can see here, hopefully, right now I have some silver screws in there, but that's going to change to black also. Then on the downslope, I had to bend the angle to a sharper degree, which essentially matches the downslope. And I'll have to do the opposite on these balusters. Is to put it here, it's going to be a much more open angle. But these angles tend to bend well and stay rigid. And everything is dry fitted, actually a little more than dry fitted. I used a JB weld to connect these corner pieces together here, and one at the top of the stairs that angled up at the 37 degrees, then made a 90-degree turn. That one's a little more tricky to cut, but I'll show you a picture of that one. I've not put in the final piece there. I will use it to pressure the posts apart so that the cable railing is taut. So this one is just tied into place at the moment, so I could get the fitting correctly. And at the top here, we have the 90-degree turn. So each piece of wood was cut 45 degrees. Then we have the down angle, which is 37 roughly, so 18.5 on each one. There's a slight gap here. I'm not the best at mitering, but maybe a little bit of wood filler, not sure yet. And then in between is the JB Weld. And JB Weld makes numerous flavors. I would get one with a high PSI rating. More later. I want to talk for a minute about the skirt board because it's a little bit important. Skirt board being this black board running down next to the stairs. And what it does is it basically fills in, you know, the shape from stair to stair. And you can see that we have the bottom cable rail, and in this case it's probably just 2 inches from it. But if this wasn't here, if the skirt board wasn't here, you'd have a gap opening, which number one doesn't look that great, and number two is probably won't pass many city ordinances for safety. So if you have this type of stair, you may want to consider that. It also allowed me to reduce the cable rail by 1 string. I had planned 13 and I went to 12 because the skirt board filled in for the bottom one. Okay, I just finished the cable railing and the handrail on all of the pieces of the stairway. This one here going up to the landing has worked out well. If I look at the adjusters, which is kind of a key to how well I measured and cut, the adjusters all look good. None of the internal stems are sticking out. And all of the cables are reasonably tight. You know, you don't want them as tight to where you're going to play a tune, but at least keeps them fairly taut. This one's a little bit loose. I do have 2 problem cables. Actually 3, I guess, maybe 4. The headache ones are the ones that are just cut too short. And this is an example of one. It's really tight, and you can see it still needs to go in about 1/2 inch. So luckily I have extra cable, and I have an extra adjuster, 2 extra adjusters, and end pieces. And the same situation here. I just cut them too short. These are some of the early ones I cut, and I just didn't measure correctly. And then the opposite trouble is when one is loose, like this one. I just made it too long, and it's all the way inside. So you have a few choices here. Obviously, you can cut a you know, a new cable if you have the parts and so forth. You can do a few other things to fix this, and I'll see if I can fix it that way. One is you could put some washers out here, and the washers then would, of course, you know, pull the tensioner back further. I don't want to do that. It will look different than the other ones. So one other way to make a loose cable tight, let's see if we can get this off and I'll show you the insides. So what I'm going to do is shorten this threaded end. It's, you know, 3/4 of an inch long or so, and I'm going to take about 1/4 inch off of it, off the end, and I'm going to do that with a grinder or cut-off tool, and then try to put it back inside and see if we can't make it more taut. And you can see I just took the abrasive tool, ground it, and then when I put it into here, it can go much deeper into the end of the tensioner. And we'll slide it in and see how we go. Okay, these just turn and tighten as they go, and in the end you put in an Allen wrench into the end of the tensioner and turn it, and I don't think I'm going to be able to turn very far. It's already gotten pretty tight. And if you need, add pliers to the cable, but I've noticed that the cables start to unwind if you try to get too tight, so just be careful about that. This one I think is going to be tight enough for us, and that's it. These ones that are short, of course, no good way to lengthen those, so I'm going to end up replacing them. And I may check a few more of these and see if I need to remove some of the screw head and make them a little bit tighter. Okay, let's take a look at the finished product here. Handrails came out pretty good shape. I just cut the ends off, nothing special, put stain on it. This bottom portion came out well. The transition from going up the stairs to flat was fine, into the landing. And I put this L bracket connection on at the end so I could adjust the tension in these tensioners. Helps by moving the baluster, in this case to the right, to give it more tension. I think ultimately all of the cable rail job came out very cleanly. It has a good look to it. It's very consistent. Cables are straight. The end cuts were pretty good, considering I'm not great at the miter box. And then from the mezzanine, the look down is good. I have a iRobot vacuum cleaner, and it's actually the Shark version. And luckily the bottom cable rail is low enough that it allows it to bump. Then I want to show you one other item. When I had to connect the two pieces of handrail, they went together fine. I did do an L bracket in each direction, so there's one on the left, one on the right to hold each piece.
Here's a picture of the handrail connection with the two angle brackets, one facing each direction. I'm pretty happy with the finished result. Here's a look from the garage floor. The lines are clean, the color's good, cable railing safe. And of course the cost is, when I had this bid by contractors, of course they were going to use prefixed kits, which are very expensive. Some of the balusters are $110 each. It was almost $7,000 for the bids to do this, which I thought was crazy.
And all in, this is about $1,000, I think $50 or something.
This slide has a list of components that I purchased. The balusters, I purchased them from this metal company specified here. You can get them at Home Depot, but they're quite a bit more expensive. I paid about $11 each. The cable railing specific items came from Musata on Amazon, and they have many different flavors of end connectors and tensioners, so you can look through to whatever fits you best. And then, of course, the handrail of unfinished oak, and then miscellaneous, a lot of spray paint, bolts, and so forth. This slide summarizes the material costs, and I won't go down through each piece of this, but I think the key summary is, what does it cost per linear foot to do one of these? And in this case, it's about $22 per linear foot. And you may be able to move that plus or minus, but I think that's a pretty good estimate of what it will cost you to do this type of cable railing system. And for the look it gives you, I think it is well worth the money. If you have any comments or questions, please leave them at the bottom. To create this video, I used the AVS video editor. It seems to be a nice, easy tool to use. Thank you for watching.